All right, so today we're going to cover 7.5 exponential and logarithmic equations. We're going to be solving. So our first example will be solving an exponential equation with a common base. So on your paper, go ahead and write 16 to the power of 3x equals 8. As you'll see here, we have an exponent that has a variable. So we need to figure out 16 raised to the power of 3 times what equals 8. And so this is a situation where we can actually get a common base here. And so 16 and 8, we can find a common base. What raised to the power? So if we look, we can actually raise 2 to separate powers to get both 8 and 16. So that's what we mean by common base. So if we do 2 to the power of 4, we get 16. If we do 8 to the power, if we do 2 to the power of 3, we get 8. So that's what we mean by common base. So if we remember our exponential properties, what happens when we have a power to a power? What do we do to combine those? A power to a power, we multiply. So basically this simplifies to be 2 to the power of 12x equals 2 to the power of 3. Now 2 to the power of 12x must equal 2 to the power of 3, meaning those variables must be the same. So we can actually say that 12x is equal to 3 as we solve for x. What's our next step in solving for x? Divide by 12, right? So x equals 3 over 12, which simplifies to be 1/4. Now we can check our work by saying 16 raised to the power of 3 times 1/4 should be the same as 8. If we plug that left side into our calculator, we want to check to make sure we get 8. Okay, now I want you to try this next one. So we'll do example number 2. 27 to the power of 3x equals 81. So write this one down, try it on your own. Okay, so if you tried to solve number 2, you would find that the common base here was 3. And so we can actually say 3 to the power of what is 27? 3, right? So it's 3 to the power of 3, 3x. And then 3 to the power of what is 81? That should be 4, right? Okay? So then we want to simplify that exponent. 3 to the power of 9x equals 3 to the power of 4, which means 9x is equal to 4. X should be 4 over 9. Questions? If you want to check your work here, you would just plug it in. We could say that 27 to the power of 3 times 4 over 9 is equal to 81 and not 84. And that should work if we plug it into our calculator. Okay, so here we're going to solve an exponential equation with a different base. There's a couple different ways we can do this, but one way that I like to look at it is converting between logarithmic and our exponential form. So we should be able to say that log base b of x equals y, and that is the same thing as b to the power of y equals x. So we'll use this to solve the next two. Yeah, we can convert between these two, right? If we want to switch. So when we have an exponent trapped on or we have a variable trapped in our exponent, we can switch it to log form to get that out of the exponent. So for instance, if we have 15 to the power of 3x equals 285, See how we have the variable trapped in the exponent? We can convert this to logarithmic form. So the way I would suggest to do that, if you're still learning what's what, is we would say b is equal to what number here?
15.
Yes. Y is equal to what number?
3x.
3x. And x is equal to 285. Agreed? So then we'll plug that into logarithmic form. Log base 15 of 285 equals 3x. To isolate x, what do we need to do? Divide by 3. So we're left with x equals log base 15 of 285 over 3. We can plug that into our calculator, so let's do that now. When we plug that in, we get approximately...
Hold on, let me put it in on log. How do I do the log? Okay, never mind, I see.
Ricardo Dorsey, please come to the student entrance to get your computer.
Yes, ma'am.
You get 0.6.
Yes? Okay, good. We good with that? Questions? Everybody remember how to type in log base 15 into the calculator?
The fact that this is very much easier than thinking it was going to be this.
See, it's just rearranging some stuff.
He's really just writing it out.
Mm-hmm.
Okay, I can do this. I didn't say that.
For number 4, we've got 5 to the power of 2x equals 130. Go ahead and try this one on your own.
X equals 130.
Okay, slow down. Let me get my...
She ain't got the color picked out right.
B equals what, 5?
5. Y equals 2x. X equals 130.
Okay, we'll rewrite it as log of what? Log base, okay,
Log base 5
of
130
equals,
equals 2x. Divide by 2.
Uh-huh.
Okay, doing by the big.
x equals log base 5 of 130 divided by 2 into our calculators, and we get what?
Hold on, wait, girl.
Y equals 5.
You getting a Q 1.512.
1.5, we'll say 1.51, approximately 1.51.
Approximately
Now, just like in the top section, we could double check these by plugging them back in. We don't have to, but we could.
I did that work and I did it right.
Good.
So, first in the class.
Look, log base b of x. So we can also solve this by using our calculator. Let's say our example is 4 to the power of 3x equals 6,000. Okay? What I want you to do is, I want you to set each of these as a y equals. So it's going to be y equals 4 to the power of 3x and y equals 6,000.
Uh-huh.
Okay? Then we will go into our calculator and plug these in. Into the y equals. So do that now. So you do second window, and then I want you to change that little triangle TBL. Instead of being 1, I want that to be 0.01. So second window, change the triangle TBL to 0.01. And then you can do second graph. You're looking for approximately 6,000
Look for approximately
in the blue.
6.
Okay, so if we find it in the calculator, we'll scroll till we're about to, what did we say? 2 point,
2.65.
Approximately 2.65. And if we check it, we could do 4 to the power of 3 times 2.65. That should give us a little bit over 6,000. Okay, that way arguably is longer, but you can just use your calculator for it. And the last thing we're going to go into is solving a logarithmic equation. So our example here is log of 4x minus 3 equals 2.
Can we enter that in the calculator?
So here, instead of taking our exponential form and putting it in logarithmic form, we want to go the other way. So we want to go from logarithmic form to exponential form. So here, what would be our base? What would be our b?
Our base would be 2.
No. Okay, so see how there's nothing written here?
Yeah. So it'd be
That makes our base 10. When it's not written, it's always 10. What would be our x?
4x.
If we go what comes after log, right? So x is 4x minus 3. Y is
2.
2. And then we've got what? B to the power of y equals x is what we should write it as. Agreed?
So it should be 10 over 2
10 to the power of 2
equals 4x minus 3. Do you have to do
equals 4x minus 3. Then we can solve for x without doing anything so far. So we can just
add the 3?
add 3. So it would be 10 squared plus 3 equals 4x. Divide by 4. X equals 10 squared plus 3 over 4.
I don't know, man.
So can we plug this in our calculator?
Sure.
10 squared.
Hold on, wait. How do I get out of this graph thing?
Do second quit. Plus 3 over 4. Gives me approximately, what actually is exactly, 25.75. And that would be our solution.
2.
Okay, so now you can go work your Math Excel assignment. Like I said before, we're not going to have a test on 7.4 and 7.5. So once you're done with the Math Excel assignment, that's it for this chapter, and then we'll move on to the next one. Sound good?
All right.